Bismillah ar-Rahman ar-Rahim. This is June 2025, 41 variant full mechanics paper. So let's try to solve. Question number 1. What is question number 1? We have a block mass 12 kilograms. Either you write down here or just make a like this for your understanding. Okay. And the plane is inclined angle 20 degrees above the horizontal and being pulled up. The particle is being pulled up. Okay, make sure. So let's try to make it. Okay. So particle is, let's say this is a particle and being pulled up with a force. Okay, the rope pulling a block in a parallel. It means applied force is not on angle, is parallel. This is a parallel force, parallel to the surface, parallel to the slope. And coefficient friction is given 0.4. So mu is equals to 0.4. And acceleration is 2. Tension. He asks you applied force, like find force or tension, same meanings. And it means it's motion on top. And the acceleration is 2. And naturally, two force will act downwards. One frictional force, one is mg sine theta. And angle is given by him is 20 degree. So now as particle is moving upwards, so motion upwards. This force is bigger. So formula we use net force is equals to ma. I can apply from here. So tension minus friction minus mg sine theta is equal to ma. Plug in all values. Tension unknown. Friction we need to find. F is equals to mu r. Now what is r? You know it very well. This particle force. First of all, what is the mass? 12 kilogram into 10. This become 120 newtons. And one force upward. This is called normal reaction. And there's always 120 cos 20. And this is naturally, I can erase it and write here 120 sine 20. Okay, as a very clear now. Okay, so I'm going to find friction force. What is friction force is a very obvious now. Friction force mu r, mu is 0.4 and r is equals to this. So r is equal to this force. I'm writing into 120 cos 20. So simple type in calculator and the value I'm getting is 0.4 into 120 cos 20 is 45.105 newtons. Okay, this value will come here. So 45.105 minus mg sine theta I wrote on top. M is 12, G is 10, so it's 120 and sine 20. And mass again is 12, acceleration 2. Just start typing matter. So tension becomes, if I type this completely and add on other side. So what is answer? Plus 24 plus 120 into sine 20. And finally, answer is coming with us is 110. Let's just check once again. 12 into 2 plus 45.105 plus 120 into sine 20. And answer is turned to be 110.147. And we always write 3 as F. So this is our final answer. And I hope so the point is clear. So question number 2 we have here three coplanar forces of magnitude 5, P5 and 10 act on a point O. And resultant of all three forces is named as a Q. X direction. What is the direction? Perpendicular to the P. It means if P is acting this way, Q will act either here or here. We are not sure where it's acting. But one thing is very clear, 90 degree or 90 degree. Perpendicular. This part is very clear. This statement is very clear. So it means net effect will be either here or here. So we can say very clear that particle, the force is acting upwards and downwards are equal, balanced. Repeat my words. When one person, let's say four people are pulling it, you can see. So if the system is going right side, so it means upward force and downward force are balanced. I think this part is very clear. So in this sense, I can tell you that upward force and downward force are equals to balanced to each other. So it means in equilibrium, you can say vertically system in equilibrium. I can say resultant of y component is equals to 0. So first of all, I will resolve the forces. So how to resolve forces? Have a look first of all. Force 10 angle 30 degree. So we will make one force parallel to x-axis and one parallel to y-axis. And this angle given. And when angle given, that is always cos component. So 10 cos 30. And where angle not given is considered as a sine component. 10 sine 30. Same way up. One component of P5 force is acting parallel to x and one parallel to y. And 60 is given here. You can see from here. So when angle given, that is a cos component, 5 cos 60. And this 5 sine 60. Now it is a very clear planning because Ry is 0. System cannot go up or down. It can move either right or left. Because he said that the resultant of three forces are Q and that is acting perpendicular. So I can tell now upward force is equal to downward forces. Ry 0 means this and this are balanced and P is itself acting on top. Let me tell you, when angle given, we can resolve sine and cos. When angle given, we can make it resolve sine and cos. But if one force acting upwards, no resolution. So I can say those two forces acting upward, this acting downwards. So upward forces equals to downward forces in case we have equilibrium. So I'm writing here P plus 5 sine 60 is equals to 10 sine 30. Once again, these two forces acting upwards, and this is downwards. And sine 30 is half into 10, we got a 5, and this is so 5 square root 3 over 2. So when I bring on the other side, I will get my answer. It did not mention here exact. If we ask you exact answer, then we have to stop this. But now we have to type in calculator and get the answer in decimal format. And answer is turned to be 5 minus, okay, 5 root 3 is equals to 0.6698. 98. Rounding 3 SF we don't want. So we will add, as we add 1 and 69, we got a 70. So this answers turn to be 0. Okay, first of all, we can write the full value. This is not important to write. Okay, so 0.67 we can write all as well, or we can write 60, so no issue at all. So this part is Alhamdulillah Rabbil Alameen, very clear. So this I'm writing here, final answer. Okay, so let's try to do the part number 2. I mean Q force. And we know that Q is acting either right or left. We are not sure about it. So, okay, and we can say that this is acting rightward, this is acting leftwards. So, which is bigger value we will take, okay? So, I think so. This is look like a bigger number. So, we can check it. So, what is a Q component? Q is basically is equals to 10 cos 30, and what the other part, this minus this, why minus, because they're acting opposite direction. So 5 cos 60 minus 5 cos 60, and just a typing in, if we ask you, and then cos 30, or I can type directly without any waste of time, and cos 60. So this answer's turned to be Q value is 6.163 SF newtons. So I hope so. The point is very clear, and we got this question completely done. Okay. And after this, we'll go for next plan. Question number 3 we have. What a question. If you read carefully, he's saying here, diagram shows velocity time graph of the motion cyclist, and diagram consists of 3 straight line, 1, 2, and 3. And the speed is when he come in the view, okay, speed is 3, accelerating for 10 seconds. This is accelerating, and acceleration is given by him is 0.5. And then he with a speed of 3, and then accelerate for, oh sorry, this is done, and acceleration of 0.5. This I said before. Okay, and then it travels speed of that same speed of 30. So squidward speed continues how much? For 30 seconds. Clear? And lastly, then deceleration is there and come to rest. So this is called deceleration. And distance traveled covering 80 meters while decelerating. So it means this is distance is very simple, 80 meters. Last triangle. So we need to find total time. If I get this time, I will add them. Or if I get this time, I mean just then add them. Or if directly, no issue. So have a look now how we can do it. But first of all, I need to find this speed. So here data is all complete data is given for this motion. How come? This 3 is called starting velocity. Okay, final velocity I want to find. This is called final velocity. Okay, acceleration is 0.5, and time, you know it very well, 10 seconds. Formula V is equal to U plus AT. V is a task to find, U is a 3, acceleration 0.5, and 10. So this is becoming 5, and that becomes 8 meter per second. 8 meter per second. This part is over, but we need to find not even that. So this means this time, this speed is 8. So I'm writing here 8. Now, students, it means this we can focus now. And what is we can say the starting. What is this speed at this moment is 8. So at here, this is you can say starting velocity 8. Ending velocity here 0 because stops, and distance traveled during this is 80 meters. Again, I can use either you can use half into base into height, or I can use same formula to get a time. No, sorry, time we can't use, we can find directly, or we can find, let's say this is a time t. So half into base into height, because this is called height, which you know 8. So this is a no need. This is no need. Okay. There's no need. Okay. So this is a time and height is 8. So what is distance area formula? Half into base into height. And I can find area is 80 meters. Base is a time, t, and height is a 8. So this is a 4. 4 to it goes there. We got a 20. So time is 20 seconds. So 2 4s are 8. And if we check it carefully, it is coming 20 seconds. Okay. So this is done, students. And total time, if I add 20 and 40, I get a 60. So total time is 60 seconds. Total time is 60 seconds. This is my final point. And now what is the next part on the next page? Because part B we have. And he said that on a given axis, sketch the distance time graph. So we have to convert VT to ST graph. And during, travel from 10 to 40, distances traveled after 10 to 40. So he has given us some numbers along x-axis. So rest we have to work for ourselves. Okay. So, whenever we going for distance time graph, we must need the parameters values along x-axis. So distances are very important. Go back. It means I must need three things. Distance 1, distance 2, distance 3. Luckily, we have it. Luckily, we have. So this distance we are looking for. So I'm finding on the same page, what is the distance 1? Trapezium rule, half into parallel side. This is a parallel side. And you can see this whenever two parallel sides. This is a 3, this is a 8, and this is a 10. Two parallel sides. So trapezium formula, half into a plus b into h. So into h, and we got it 5, and this is 55. We got a 55 meters. Done. This is done as well. So it means when this time is 10, distance is 55. And this third time is 30. And what is distance I need to find? How to find rectangle area? And rectangle, this is a 30 and this is a 8. So 30 into 8, 240. I show you below here. 30. So what is distance S2? Length into width. So we can say length is, the width is 8. And length is 30 meters, 30 seconds, 240. So it means we got both times 55 and 240. And last is 80. Repeat my words. This we know all three distances. And now we are eligible to do it. So 55. Okay, let's go next page. So situation is what we have. Let me write all. When time is 10 seconds, distance is traveled till that 55. And when time is 40, okay, in the not 40, like 10 to 40, okay, 10 to 40. The distance traveled is basically is 240 and 240, and then add 55. 55 because the first 50, okay, let's try to make it right here, roughly 55 here. And if I add them 240 plus 55, it becomes 295. So approximately I take here 295. Okay, this is done. And last number, when time is 80 seconds, 80. So I will make 80 here, not 80, so 60. 60 seconds, which I got later on. And I will add 80 furthermore because 80 is there. So for 5, 9 plus a 7, and I got 375. I hope so. The point is very clear how I got the last, 375. Yes. So once again, just review only 1 minute. But he said, let me check. Yeah, okay. So we got a 295, and now we can make it. Before I start, I will just tell one thing. What is this diagram representing, and what is this representing? This you must know it. If you don't know, we can't solve it. So this diagram, look at it. If I draw a gradient here, this is accelerating. This is more accelerating. This is more accelerating. So it means when you're speeding your car, this representing. So when you're accelerating, this is called diagram for acceleration. But hold on, what is deceleration? So this diagram is for deceleration. How come? First, it has a bigger acceleration, then it becomes smaller and smaller. So it means when you're stopping your car, this is a diagram for stopping. So I mean going to stop. So this is for acceleration, this is for deceleration. So don't forget it. Let's try to do it. Now uh, I'm going to start. And wait a minute. Just a minute. I just make it more clarity. And 1 minute. Maybe I'll just once again, I concentrate. Maybe I explain in reverse, please. 1 minute, please. So if you talk about here we have a acceleration, but a less acceleration. Here we have more acceleration. You see all these 0 gradient, 1 gradient, 2 gradient, 3 gradient. So gradient is increasing. So this means that we have to express. So this yeah, this is correct. Okay, this is accelerating and this is decelerating. So now concentrate and we are going to finalize it. So just keep in mind, this is accelerating and this is decelerating. So first we have, 0 to 10 accelerating. So how we make it diagram. Check it. This is, I made extra actually, but okay. This accelerating till 10 seconds. Then we know 10 to 40 constant speed. I will mark 40 and this 295. I think it is approximately here. Straight line because constant. And now I'll make it here 60, approximately here 60. And I will mention what is the distance for it. It is, let me check one finally. 200 and 240 plus 55 and plus 80 is a 375, correct? So 375 is somewhere here. And now I'll make this diagram here. So when I will, this is the ending point. This is ending point. Okay, so this is meeting with this number. So now I'm going to show you this. The student, this is decelerating and this is accelerating. I think that it is a clear and diagram somehow is clear, but you have to show the bending part. Okay, it should not be straight. It not be straight like that. Wrong. Okay, I hope so. The concept of the question is completely over. Question number 4, we have a lorry of the mass 18,000 is traveling along a straight road. On a horizontal sectional road, the power of the lorry's engine is constant, and there's a constant friction force 1600. Okay. Now further, the steady speed. What is steady speed means? A constant speed, acceleration is confirmed 0, which the lorry can maintain with an engine power of 30 speed. Okay, speed is a fix. Okay, and find the P. So what is the basic formula we use? Basically, formula you use, net force is equals to MA. Net force is equals to MA. Applied force minus frictional force is equals to MA. But power formula is FV as well. If I bring this V down, I get a power P by V. And acceleration, you know very well, is 0. So friction will go on the other side. We get this form. So V multiply with there, P is equal to FV over friction is 1600 and speed is 30. So 48. So 48,000 watt. Or he asking in watt. So no need to convert it. This is our final answer. And let's go for the part number 2. So at an instant when the speed of lorry is 16, the engine is working the power 40 kilowatt, find acceleration. So same formula, I'll use same formula, okay? Same formula I'll use. I'm using same, but make sure this time no acceleration is not 0 because we need to find. And force formula is P by V. P by V minus friction equals to ma. Power is 40 kilowatt, so 40,000. Speed is 16. Friction is 1600. Mass we have how much? 18,000. And we are going to find. So 40,000 divided by 16 minus 1600, and I got a 900. So 900 is equal to 18. This one, 1800, 80,000. 1,000, sorry for that. This is a one more zero. So when we divide, the zero cancel out. And 9, it is a so it has become a half because 9 divided by 180, not half, is 0.05, not 0.5, 0.05 meter per second square. Last part, when the lorry has reached speed of 20, so speed is 20, it begins to ascend. Ascending means going up. So it means situation is now what? It's going up. Okay. So this is a power or force naturally. And what is mentioned here? Angle alpha. So this is angle is alpha. Okay. And what is said? He said further, engine works with the power 120 kilowatt and no change in the speed. Okay, fine. And friction force is same, find alpha. So you know when particles traveling upwards, we act two force acting downward, frictional force and mg sine theta, weight component, alpha we can say. Out of right formula, same formula, net force equal to ma, but this time applied force minus friction minus weight component, because motion is upwards, force is bigger. Which is bigger? I take that one. Applied force minus frictional force minus mg sine theta. Alpha is equals to ma. According to he said speed is not changing, no change in speed. So it is acceleration 0. Acceleration is 0. And for force formula, you know, P by V, and minus friction minus mg sine alpha is equals to 0. I leave what is this one? Power 1 to 0 kilowatt. So I make it 3 more zeros. Speed is 20. And friction, I'm leaving it here, 1600. Mg sine theta, bring on other side. M is 18,000, and then T, and this 10, and sine alpha. Now, just a matter of typing in calculator. We will get our answer 1, 2, and 201, and 1, 3 more zeros. Divide by 20 minus 1600. I got a 4400. And this will divide down 184 zeros. I have left sine alpha only. So, so I'm going to take a sine inverse. Oh, 11 over 450. 450. So sine inverse. My answers turn to be 1.4 degree. I hope so. The concept is very clear. And question is completely over. The number 5 we have. And what question number 5 is a particle of P mass m, okay, m kilograms, have a speed is u, and momentum is 4, and kinetic energy is 16. Okay, we need to find two unknown constants. So what is the formula of the momentum? P is equals to mv. Momentum is 4, mass is m, and speed is u. So we got one equation. Now kinetic energy. What is kinetic energy formula? Half mv square. Kinetic energy is 16, mass is m, and speed is u. So I got a mu, I got a, these two multiplies there, I got a 32. So I have to go for solve them simultaneously. And I think so, if I divide second equation by first equation, what happened? It comes up, it goes down. So 32 and mu square up and 4 down and mu down. In the middle equal sign. Mass cancel, u cancel a power, and this 8. So I got u value 8. And now I can plug in this 8 here, and I got a mass is equals to half kilograms. So part number B. A P is now, it means same P, same particle, it means same mass is 0.5. And thrown to a smooth, it means no friction, speed of v towards q particle of mass this stationary. It means two particles are there, one this particle and one this particle. So let's try to do it. So this particle, copy, paste. There's a p, all right, write down p, q. P mass is a 0.5, q mass 1.25. And this speed is v given by him. This is stationary, so 0 speed. This is just before. This is just before. Let's talk about just after. Because he mentioned our next line is a collision. So just before and just after. And he said that after collision, collide, okay, P, velocity of P is W. This is W. And velocity of Q is 2W. And loss in kinetic energy is 25. So loss in kinetic energy is 25 joules. And again, we have to find two unknown constants. So first of all, what is the law of conservation of momentum? You know, m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. So if I multiply them, multiply, and multiply. So first situation, I get a 0.5 v. This I get a 0, 0.5 w. And here I got a 1.5. And what is 1.5 into 2? This is naturally 2.5. So I'm writing directly 2.5. So I got a 0.5. The V is equals to, this is a 3W. And if I divide it down, so it means 3 by 0.5 give us 6. So we got a V is equals to 6. Okay, I'm writing it now here. V is equal to 6W, equation number 1 done. Now we have to go over towards loss in kinetic energy. What is the basic formula? First of all, kinetic energy before collision, B for before. And before this is 0, so no need to calculate, only this to calculate. And formula half mv square, mv square. And we got naturally 1 by 4, or yes, so 1 by 4 v square. And what is kinetic energy after? So we have to calculate both. So what is the formula? Have mv square, because it's w, plus have mv square. This is v. I think clear point. Now to complete it, and if I check it, what I get finally, this is a 1 by 4 w. Yes, 1 by 4. Half into 0.5 is naturally 1 by 4. So 1 by 4 w square. And what about this? So it becomes 1.25 into 2, because this power 2 will cancel with 2. Or you can say 2 square 4 cancel, we got a 2. So this is coming with us 1.25, it's becoming 2.5. In fraction form, 2.5 is 5 by 2. So this becomes 5 by 2 w square. I hope so clear. And now if I make it to 1, so 1 over 4 plus 5 over 2, it giving us 11 over 4 w square. Now I'm writing according to situation, this is equal to this one. So I hope so point is very clear. So 11 over 4 w square is equals to how much loss? Check it, 25. And sorry, this is a subtraction. Sorry for that. Because what the loss means? Final, after, before, because before collision is a high energy, after collision is a smaller energy. So this minus this, I repeat my words, 1 over 4 v square minus 11 over 4 w square is equals to 25. I repeat my words, kinetic energy before collision minus kinetic energy after collision is equal to the loss. So if I multiply, therefore, multiply by 4, we got a v square minus 11 w square equals 200. So when this plug in it here, I will get a 6w whole square minus 11w whole square equals 200. And now student 6, these are 36. So 36 minus 11, I got 25w square. And divided by 100, I got a 4. Yeah, 4. And take a root of the both side, we got a 2. W is 2. And this value w, I plug in it here, so we got a 12. So V is equal to 12. Alhamdulillah Rabbil Alameen. I hope so. The concept of the question is completely clear. Question number 6, we have two particles P and Q of masses 0.3 and 0.6 respectively. So P is 0.3, Q is 0.6 attached, okay, and with a string. And he mentions that P lies on a smooth plane AB. So it means AB, no friction at all. So friction is 0. And angle is theta, you can see. And sine theta is given 0.4. Okay. And other angle is 30 degree. And string is taut. And particle released from rest. So far, and BC for part A, he has given smooth. So here friction also 0. So find the tension and string and acceleration. So first of all, what is method? This is into 10. So into 10, we got a 3 Newton force. And weight component would be naturally 3 sine theta. What is the angle? Normally, basically, is mg sine theta. M is this into 10 into sine theta. And tension towards pulley, that's for sure. Okay. No friction, I'm not making here. And this component is, what is 0.6 into 10? 6. So 6 sine 30, because the angle is 30. Now we can see, we will make two equations. and he says particle. Okay, and from here we can see here. So this is a bigger mass, so this will fall downwards. So motion is this way, and it will move up. So I will start from here. And what is the basic formula we use? We'll use formula net force is equals to ma. We use this formula twice. Okay. So when you talk about the Q particle, so this minus tension equals to ma. So I can say 6 sine 30 minus tension is equal to m times 2a. 6 sine 30 is basically is 3. When you talk about the P particle, what happens then? Because moving upwards, I'll start from tension. So tension minus weight component. Tension minus weight component. So 3 sine, and sine theta is 0.4. I'm replacing here 0.4. And 0.4 is equal to ma. So I'm getting T minus 1.2. And I'm going to solve them simultaneously. Equations done. Now I'm going to copy both equations. And this equation and this equation. Now, obviously, this tension cancel. From 3, 1.8, subtract 1.8, 0.9 acceleration. So acceleration becomes 2. meter per second square. And he is asking further, find the tension. So just plug in this number in the previous equation, any one equation, I plug in it here. So when I plug in it there, so it begins tension minus 1.2, 0.3 times to 2, 0.6. So 1.2 and plus 0.6, 1.8 newtons. I hope so the point is very clear. Let's go for the next part. Next part we have, it is a given. Instead the plane BC is rough and work done against a frictional force when Q moves 2 meters down. The work done by friction force is 1.2, 1.8. So work done by frictional force is basically 1.8. And we can assume P does not reach pulley and Q doesn't reach C. So this idea is clear, and use energy method to find speed of Q when it moves 2 meters down the plane. So first of all, what I will do, this diagram is very important. Okay, all right, just okay, 0.6 and 0.3. I'll make roughly. Here 30, here theta, and pulley is here. So what will happen, students? So particle is here, will move up. And this is a string. This particle is here, will move 2 meters downwards. Okay, this mass 0.6 and this mass 0.3. Situation is what? This triangle, I will get it. You can see here, 90 degree. and this theta. Same way, I'll get this triangle here, theta, and is a 2 meter, is a 2 meter. So we will consider this as a ground level. Though it's not a ground level, this I will take as a ground level. I will take as a reference. Similarly, this I will take as a ground level. So now what is the technique? We will use magic formula. And what is magic formula? Work done by applied force, work done by frictional force is equal to kinetic energy plus potential energy at a starting point. Sorry, ending point. Ending point minus starting point. So ending point minus starting point. Ending point means kinetic potential energy at this, or the system we talk about, not one particle. So we talk about particle Q and we talk about particle P. So first of all, this is zero. Reason because it is coming due to its own weights. So this is zero, very clear. And we will find one by one all values. Okay, so this formula is very clear. I'm going to use it. But first of all, this component is zero. Work done by friction force is given by him is 1.8. So two values we are sure. Now, so students, how to find it? First of all, I'll find this height. I need to find h1, this h2. How to get h1? So h1 opposite by hypotenuse is sine 30. 2 multiplies there, h1 is becoming 1 meter. But when you talk about this one, h2, so opposite by hypotenuse, h2 by 2 is equals to sine theta, which is, I think so, 0.4. Look, I show you. You can see 0.4. So 0.4. So when I use 0.4 here into 2, so I got h2 0.8. Okay. So both heights we have it now. And what is because starting, so what is because this first of all, I will find out the kinetic energy before, and just kinetic energy is okay. Kinetic energy at ending and kinetic energy at start. I will find out all four values. So kinetic energy of the system at the start. At a start, kinetic energy at a start. So I just write start here when a particle moving. Okay, starting what is energy here of the p particle? That is a zero. Why? Because particle starting from rest, so that is zero. And what is energy at this moment? That is also starting, so this is zero. This is so obvious. So kinetic energy at start is zero. And what is a kinetic energy at the end? So it means this particle reach here. What is this? And this particle reach here. What is this? I'll find both half m v square. And same here, half mass 0.3 v square. Okay, if I type this in calculator only, so I get a 0.3 plus half into 0.3, I get 9 over 20 v square. So this is a kinetic energy at the end, I got it. Kinetic energy at the start, I got it. Zero is okay, I can say zero directly. And now I'm looking for the potential energy at the start and potential energy at end. So what is the potential energy at a start? So of the whole system, Q is here, has a height of this one, so mgh. M is this and height is 1. So mgh, m is 0.6, g is 10, a height is a 1. Plus, what is this? Particle, because when it was starting, Q was here, so it has a potential energy. When it was starting, what is potential energy? Zero height, because ground level. So I got a 0. So this is very obvious. I can say here, this is a 6. But what is the potential energy at the end? N means like when particle travel reach here, so it is a zero because it reach the ground level zero. But what about this? This is a mgh, mass is a 0.3, h is 0.8. So mg into h. So I got a 8 times 2.3, it become 2.4. So 2.4. Now, students, we are ready to plug in the values in the formula and we get our answer. So what is kinetic energy at the end? We have this. Of the system I talk about. What is potential energy at the end? 2.4. What is kinetic energy at the start? That is a 0. Positive, negative, negative. What is potential energy at the start? Our system is 6. Now I'm going to solve it. Negative 1.8 and this goes there. Negative 2.4. This goes there. So plus 6. And 9 over 20 v to power 2. Now, if I type in calculator, student, negative 1.8, negative 2.4, and plus 6, I get a 9 over 5. And this 20 and 9 will come on this side. 9 cancel, we got a 4. So v to power 2 is equal to 4, and v becomes positive 2 meter per second. I hope so. The concept of the question is very clear. Question number 7 now we have. A particle x moves along a straight track starting from O with time 0, and displacement is given this formula. And find the time and x is at rest. Rest means velocity is 0. Find total distance traveled by the x from 0 to 16. So first of all, you know very well we have 3 levels. Displacement, if we differentiate, we get velocity. If we differentiate, we get acceleration. So differentiate and differentiate. But if I want to come down, integrate, integrate. So right now I am on displacement level. I'm looking for velocity. So I will differentiate. So S is equals to, this is given by him. So ds by dt, 3 already exists, power comes down from power 1 less. So from 3 by 2, 1 less, we got a half, and 60 becomes 6. So we got a velocity 9 over 2, and 9 over 2 and root of t minus 6. So I will plug in velocity 0 because particle is at rest. So when I plug in 0, 9 over 2 root of t minus 6. 6 come on this side. 2 multiply, we got a 12. 9 divides. So 3 fours are, and 3 times. So squaring both sides, we got 16 over 9. So time we got it in seconds. Okay, what is asking next? He asking the time, we have done it. Second part, find total distance. This is important part here. So have a look here. Or we can do this part. So displacement. How I add this total distance, or not displacement, distance traveled 0 to 16. So first of all, best way, we will plug in different situation. First of all, best technique, plug in 0. But no, you know it very well, when time is 0, s is 0. Reason, when I plug in 0 in this equation, I got a 0. But when time I plug in, because particle stops at 16 over 9, I'm bound to replace 16 over 9. So what s turns to be? Check it. So 3 times to 16 over 9, power 3 by 2, minus 6 times to 16 over 9. So this I'm going to type in calculator. 16 over 9 power 3 by 2. And minus 6 times 2, 16 over 9. And we get a negative 32 over 9. What negative means? It is going back of observer. So I'm going to show you the situation, what he's talking about. Whenever this is observer, let's say this is observer. If the particle goes away, so displacement will take a positive, will take displacement positive. When particle goes backwards, will take negative. So that is why this negative means it is going backwards. So now we want to plug in last time 16. So when time is 16, what happens then? So we will plug in again the formula. Okay. I'm going to type in calculator, simply replace by 16, not 16 by 9. And answer is coming with me is 96 positive. Very interesting part. When positive, I said before. So basically, if you see the diagram, so this is observer. So when time is 0, it is a beside observer. So first of all, it is going backwards. So first it's traveling backwards. How much moved backwards? And 32 by 9 meter. I'm not writing negative sign. And afterwards, what is displacement when time is 16? Displacement is when time is 16 over 9. And when time is 16, so its displacement is 96 positive. It means basically particles starts from here first, it goes backwards, it turns, then is crossing the observer and reach here. So I hope so you got a point. How much distance traveled total? If we check it, it is not hard to calculate now. Total distance traveled is first it's moving backwards 32 by 9. Then it reached here and again 32.9 and then 96. Because this is a this is a displacement equation, not distance. So displacement from observer is 96 when time is 16. So 32 by 9 one time, 32 by 9 second time, and plus 96. So if we check it in calculator, so 32 by divided by 9 and plus 96. So answer is turned to be 928 by 9 meters. In it is a rounding 103.11 meters. So 1 meters. Okay, rounding 3 SF. I hope so. The concept is very clear. Let's go for next part. Next part, students, we have a second particle y moves along another straight track and starting from p at time is 0. Okay, and acceleration given by formula here. All right, and velocity of the when p leaves is this one. Leaves means when time is 0. So when time is 0, velocity is 7.5. And what further he says, the velocity, when velocity is by negative 9.6, show that a displacement of x from O is equal for both x and y. So repeat, look, this x and this the y. Both displacements are equal. So we are looking first expression of velocity, but problem I have acceleration. So I'm writing acceleration expression. And I taught in the previous page, I just bring back. So when we talk about, we have acceleration level, we want to come down, integrate, again come down, integrate. So 2 time integrating, I will reach on displacement level. So let's start. Now, first of all, I will integrate the acceleration expression. So when I integrate, so what I will get here, I get velocity, and here integral sign 0.8 minus 0.6 t and dt. And you know it very well. This is become t, and here increase a power by 1 divided by same, and plus c1 or c. And we know that when time is 0, this is given by him, so I'm going to plug in it here. So when time is 0, velocity is 7.5. So we can find v easily, c easily. So I'm putting 7.5, 0, 0. So C value becomes 7.5. This I'm going to plug in back in equation. V is equal to 0.8 t, negative 0.3 t square, and plus 7.5. So I got expression of velocity, but what a question he is asking from us. He is asking from us is um, when velocity is negative 9.6, show that this is equals to other, okay? So it is very clear. We have to mention that we have to find the time when velocity is negative 9.6, and we need a time. And then that particular time, we have to check it displacement for the x and q are equal. So job number 1, I'm going to plug in negative speed velocity here, put velocity negative 9.6. Let me check again. Yeah. So I'm going to plug in negative 9.6, 0.8 t, negative 0.3 t to power 2 plus 7.5. I bring this all values left side and rearrange them. I'm getting 0.3 t to power 2, negative 0.8 t, and 9.6 plus 7.5. I'm getting 17 point. Here I'm applying quadratic formula, negative b plus and minus b square minus 4a into c divided by 2a. And first of all, I'm going to calculate. Okay, so yes, so what is a value of a 0.3, b negative 0.8, and c is negative 17.1. And I got a first answer is coming with me is 9 seconds. The second answer I'm getting here, negative 9/3. This ignore, and this is my answer. Now, what is the planning, students? We have a very clear planning now. We will use this 9 seconds in both displacement expressions and find out, because you want to prove it, displacement for x and y are same. We have to prove it. So first of all, I will plug in for the x particle. What is displacement expression for x particle is here, which I'm going to copy paste from here. Which I'm going to paste here. So this is a for x particle. So I'm plugging that same time. What's time? 9 seconds. I'm going to plug in now here. Okay. So when I plug in 9, so t is equals to 9. Displacement for x is what? So 3 times 2, what is the situation we have? And 9 to power 3 divided by 2, which is a 6 into 9. We get a 27. So we got a distance for x. Now, students, we are going for y. But problem, do we have a displacement expression? No, we have to integrate from here. And student, we have to integrate, so I can do directly. I can do directly without any hesitation. Two choices I have. One choice is if I do with the plus c or with the limits. With limits, I can do easily, and I'm going to complete it now here. S is equals to integral 0 to 9. 9 is reason because still 9. And 0.8 t minus 0.3 t to power 2 plus 7.5 dt. Let's try to do it. Increase a power by 1 divided by same. Increase a power by 1 divided by same. And 7.5 t. 0 to 9 limit. So when I plug in 9 everywhere, let's see what answers turns to be. So 0.4 into 81 minus 0.1 into 9 to power 3 and plus 7.5 into 9. The answers turn to be 27. When I plug in 9 everywhere and then I plug in 0 everywhere, it gives you 0. So displacement for x is 27. So proved. And both distance displacement, I think displacements are equals to each other. I hope so. The concept is clear, and the paper is completely done. Best of luck for your upcoming exam. May Allah help you. Assalamu alaikum wa rahmatullahi wa barakatuh.